So, and now let's wrap up stream 3 with Alexey Khoroshilov, Senior Data Science at MENA Financial. He will share how Kedro pipelines can be used to build reliable credit risk models in fintech startups, especially in resource-constrained environment. And yes, Mr. Alex, Alex, you can start.
Hi, everyone. I really appreciate your presence today, especially at the end of the working times, and I hope that my presentation won't be so long. So, as you know, my name is Alexey Khoroshilov, and I'm a senior data scientist at MENA Financial. The last 7 years of my career, I was developing credit risk models, and during this journey, I've used a lot of tools and frameworks. Finally, I came to a pipeline concept. So today I will discuss which one, to my mind, is the most appropriate for developing models in credit risks. Let's move on. So before we jump into the discussion, let's first cover the context that made us start researching pipeline instruments. In addition to typical problems like chaos with code, problems of compatibility of multiple versions of Python libraries, we faced with the problem of knowledge transfer between team members and the impossibility of repeating the process of building a model. What does it mean? Well, it's obvious that very often people don't work forever at one place. So it's inevitable to lead the development process in a way that any team member could continue any project from where the last person stopped without any loss of time. In addition, it was necessary to form a certain methodological base for managing and structuring ML projects, which would help to reduce operational risk and improve interaction with the validation department. Besides small fintech companies, this is especially relevant for banks that are currently in the process of switching to the IRB methodology, during which regulatory risk models are subject to very strict control by the validation department. In fact, the validator should repeat the process of building models after you, and for this, the process must be extremely transparent. All these difficulties showed us that we required a detailed, organized, and flexible plan for developing our models. As we dive into our discussion, let's consider the most fundamental problem that all risk departments work hard to solve. This is the problem of predicting client's default. What's default? A default happens when a client takes a loan from a financial institution and does not pay it back. This impossibility of being able to pay back loans can damage financial institutions and the economy as a whole. To combat this issue, we use PD or probability of default models, the models that predicts if a borrower is going to default or not. These models help institutions to make beneficial lending decisions, manage credit risk, and fulfill compliance restrictions for borrowing. Knowing how to build a PD model and its other functions assist in optimizing strategies for credit management. This is just one of many things that we'll cover later on this presentation. And here's a fun fact for you. If you ask Kandinsky neural network to generate an image based on phrase, show me default credit obligation, that's what you will get. A dejected little figure full of despair. Honestly, I understand him. I feel pretty much the same way every time when my monthly mortgage payment comes due. Now let's back to our task. Building PD models in banks is a complex process. Its full documentation can easily span hundreds of pages. However, the main steps of the process follow a widely recognized ML methodology named CRISP-DM, cross-industry standard process for data mining. Here's a simplified breakdown of key steps. Well, the first one is business understanding. We start by defining the problem. In our case, the goal is to predict client default events. The next stage is data understanding. This involves analyzing all available client data, including records from credit bureaus, internal bank data, and external aggregators. The third stage is data preparation. At this stage, we pre-process data, create features and variables for future models, handle outliers, and correct any data errors. The next step is the most interesting, of course, the modeling. With clean data, we build and test different candidates, such models as decision trees, logistic regressions, boosting, and neural networks. The next stage is evaluation and documentation. Once we select the best performing model, we evaluate its impact and document the process in the whole process. So, and the last stage is development and monitoring. If everything checks out, the model is deployed into the production and the monitoring system is set up. So we just track performance and next repeat the circle again after the model starts working bad. So actually, the entire process functions as pipeline, a structured sequence of steps designed to achieve a clear result, a production-ready model. On paper, following this sequence seems pretty straightforward. You could even execute it step by step in Jupyter Notebook without much troubles. But there is where things get messy. Without a proper pipeline, model development becomes chaotic. You constantly revisit previous steps to test new hypotheses, while business stakeholders keep sending new feature requests. At the beginning of the project, things may still seem manageable, but as complexity grows, it becomes unclear where the process actually ends. And if you inherit such project from a former colleague, especially when deadlines are tight, it's a nightmare. Version mismatches between Python and libraries only make things worse. To avoid this, we need a standardized project structure for a team that remains consistent across all models and stages of development. So naturally, we start researching solutions and quickly realize that there are so many tools to choose from. The real challenge is selecting the right one. The first and the most obvious, of course, containerization. Each model should be developed in its own isolated container in Docker, ensuring consistency and reproducibility. A typical setup looks like a Docker plus any Linux. It could be Ubuntu, Debian, any. Then we install core tools inside of it, like Git. And if you want, you could, if you don't use pip, for example, you could use Miniconda. And the last component is the thing that named ML pipeline, a structured pipeline to organize model stages and ensure seamless reproducibility. With this setup, we eliminate dependency conflicts, improve collaboration, and make it easy to reproduce results, bringing us to one step closer to data science happiness. As I mentioned earlier, there are many ML pipelines tools available, but today we'll focus on three popular ones. The first one, ZenML. It's a semi-proprietary framework from a small IT company in Germany. Despite having a team of just 20 people, their website claims that thousands of companies rely on these tools. The next one, Metaflow. It's developed by Netflix. This framework was originally built for internal use, but became open source in 2019. And the last one is Kedro. It's an open source framework from Quantum Black, which was later acquired by McKinsey. In general, all three are quite similar. They provide structured workflows for ML projects, have solid documentation, and even offer VS Code plugins for easy integration. So which one is the best? Well, unfortunately, there is no single best answer. Each tool has its strengths. I've listed a few key comparison points in the table, but there are many more factors to consider. For me, it turned out that Kedro is the most convenient and effective choice. My main goal was to standardize risk modeling projects, and Kedro was the only with a pre-built template that fits my need perfectly. That said, I highly recommend to test all three to see which one would best for you and your special case to use. So when selecting an ML framework, the first question was like, what type of task are you dealing with? The first one, if you here, for example, for ad hoc analytics, there is no need to complicate things. If you're conducting, for example, one-time analysis, such as retro testing, a data set from provider to evaluate their features or scores, keep it simple. Just use Jupyter Notebook plus AutoML library like Light AutoML, and that will do the job efficiently. For large-scale ML project, a Jupyter Notebook alone won't be enough. So the next question that we should answer, do we need scaling or not? If we need that our computation should calculate it on multiple cores, resources, and so on, clusters, so it's better to use Metaflow because, well, it's easy for scaling, and that's why I recommend it to use. If no, we don't need to scale, we should answer the question, is a project or not? Do we need a fixed structure or not? So if we need fixed structure, of course, this is Kedro. That was my case because, as you know, in risk models should be very transparent, and any validator should repeat it after you. So that's why, for me, Kedro was an optimal choice. Now let's walk through the template, which serves as the backbone for Kedro projects. This project template is structured into 7 main folders, each serving a specific purpose. The first one, conf. It stores configuration files. The next one, data, folder for data. Here, the stages of data. The next one, logs for documentation, notebooks for drafts, for testing hypotheses. This is SRC, it's the core directory containing all source code. And the last one is test, just for if you use unit tests, you could save them here. Well, if you ever worked with cookie cutter, the structure will feel instantly familiar. Let's do a closer look to key folders. Key folders is conf and SRC. So the first one, conf. This folder contains 2 subfolders, base and local. The base folder stores local environment configurations, and local stores local environment configurations, and base stores the data catalog, where we define datasets names, storage paths, and loading mechanisms. So the next main folder is SRC, and here's where we keep the entire ML pipeline logic. It contains all script functions and pipeline definitions necessary to execute the model workflow. With this structure, we have a clear, organized framework, ensuring that every model follow a consistent approach from start to finish. Now let's dive deeper into how the pipeline is set up within Kedro. So, in the data catalog, as I said earlier, it's one of the main folders there. Our data sets can be read or written in various formats. Some of them are shown on the slide: S3, Microsoft Azure, SQL, and so on. The most popular text files, such as Pickle, Parquet, CSV, and so on. It could also be as partitions. So then you pick the path not to the file, but to the folder. It can even be an SQL script that could execute it in start. So you don't need to download it before, save somewhere on hard disk. Just write an SQL script and it will work. The next file in the folder is parameters. Parameters contain some global variables that are used in the project, such as random seed parameter, test train ratio, correlation threshold, and so on. Here I did not mention, but in local, usually we keep our passwords, in the files in gitignore, so you won't be able to download it on your GitHub and show everyone your password. So it's already received the problem. So the next one, we're moving to SRC's folder. Here we create directories where we call them pipelines, the directory, and the pipeline file in the directory, and the file node. So each pipeline is represented as a folder, as I said, and its name determines the pipeline's names. Inside each pipeline folder, you'll find two key files, nodes and pipelines. Sorry for that. Pipelines.py, it defines the sequence of execution for different parts of the pipeline, known as nodes. Nodes contain all the functions that the pipeline uses. Now let's break it down further. Pipeline.py, it defines how nodes are connected and the order of execution. The nodes py, actually here could be any logic processing, pre-processing, modeling, and other functions that you are using in your ML projects. So we've already talked about the pipeline itself. So I would like to draw your attention on following Kedro extensions, which are called must-haves, of course. And the first one is Kedro Viz. So the first tool I'd like to highlight is Kedro Viz, and it's a powerful visualization feature within Kedro. It provides structured graphical representation of ML pipeline, making it easier to understand and analyze. But it's more important. But it's more than just a static diagram. It's a fully interactive experience. In a moment, I'll demonstrate its capabilities as we walk through a practical sample. Here's we select the pipeline, for example, pre-processing, select any nodes, you can check and filter. So check parameters, select only nodes, then they would be displayed on the nodes, and so on. So it's a graph that even you could show code, right? It's a graph that visualize your projects. It's very useful thing when you show the project to any business stakeholders or even for your understanding. And here's the next video is filtering by tags. You can tag each node and select only that node that are tagged. And inside of the graph, we can select correlation metrics and to see the coefficients of regression metrics and so on. So it's a really cool feature. The next one, beyond of visualization, Kedro is integrated with the mail flow. It makes simple to track and model development and model management. Setting it up very straightforward. Just install ML flow using pip and activate ML flow logging with the command Kedro ML init. This command generates an ML flow.yml file. This is a file in the directory where we store and configure the host and the port for ML interface. If ML flow is running on a remote server, we can specify the necessary credentials in this file, enabling direct logging of experiments without relying on local instance. So, next slide. Before we begin, it's assumed that you are familiar with Docker. You could use any Python-based image, whether it's a miniconda or an official Python container from Docker Hub. The choice of image isn't crucial. Next, install Kedro, KedroViz, and MLflow for tracking. This can be installed like any other Python libraries. Once all dependencies are downloaded and installed, verify the setup by running Kedro info. And here you will see the text in the command line. If everything is okay, you will see the label Kedro. Navigate to the directory where you want to create your project and run the command in cmd like Kedro new. After that command, you name here of the name of project. Type the name of project here. I typed MIPT, and the next step is select tools which you would use. The first is basic linting with RAF, test, environment, specific logging options, docs. It's a Swing-based documentation setup, data folder, do you need it or not, PySpark, and KedroViz. So I usually select all of them, just type all, and the whole structure will be created. Once the project is created, Kedro automatically generates a well-structured, as I said, and I want to show you the next is following directory mute.conf base, right? Here's the project, and this is where configuration files are located. We'll explore its contents and how it fits into the overall workflow. So in catalog.yml, we define the paths and types for datasets, both existing ones used for training and testing, as well as any that will be created throughout the project. These datasets and files will be organized within data subfolders. This includes preprocessing, feature datasets, pickle files, storing trained models, visual assets such as charts and graphs. So all these things you mention in this file. The next file is parameters.yml. On the other hand, it's a storage for global variables. This can include, as I said previously, random seed, the number of features that should be selected for modeling, different data and columns, the names of columns, and so on. Sorry, just technical troubles. Yeah, here we talked. Now we move to the core of our project, defining functions and structuring the execution using pipelines. For simpler projects, we typically create 2 pipelines, each organized into its own folder. The first one, data preprocessing, and the next one, data science. Data preprocessing focused on data cleaning, transformation, and feature engineering, and the data science is dedicated to feature selection and model training. Inside each folder, we create a notes.py file. In data preprocessed notes.py, we implemented all functions that are related to data preprocessing and feature computation. In data science notes.py, we write functions to feature selection and model training. These modular functions will be assembled into a pipeline, ensuring a structured and reproducible workflow. Depending on Kedro version, you may need to input partitioned data sets, and it depends on a version of Kedro. You should import it or from kedro.io or another relevant model. It depends on version. So partitioning of data allows you to split the large data sets into smaller manageable chunks, combined with lazy loadings and saving. This enables efficient processing of data sets that don't fit entirely into your RAM. This is especially useful when working with large data sets for feature engineering. Once we finished with nodes, right? Next step is to write and to define the pipeline. In pipeline file, we import all functions from the nodes and parameters from parameters.yml as inputs. So the pipelines takes functions, datasets from catalog.yml as inputs. The outputs consist of processed files, which are also registered in the catalog. To ensure the project recognizes our pipeline files, we create a init.py file. Now let's execute our pipeline. First, navigate to the root directory of the project. Then launch the pipeline across all available CPUs using the following command: Kedro run, and to define runner as thread runner. As the pipeline runs, you see that everything is displayed in your command line, where you can also track any errors if they occur. Once the pipeline execution is ready, we can visualize it using Kedro. However, it's important to note that you don't necessarily have to run the pipeline first. The visualization schema is saved regardless of it. To launch Kedro, it's also in Docker Compose configuration files, and then connect after load function. Kedro run / host and connect port to make it available on your local machine. So Kedro allows to merge multiple pipelines into a single view. Here we can see all nodes from both pipelines visualized together. By clicking on any node within Kedro, we can zoom in and analyze its details. This helps in understanding how individual components function within the pipeline. If a node produces an output, you can easily inspect it within Kedro. This is particularly useful for debugging and understanding how data flows the pipeline. While our experience with Kedro, well, it's still on pilot stage, and a comprehensive review of its drawbacks is not possible yet, but we have already encountered a few challenges. The first one is initial development slowdown. In early stages, the model development process tends to slow down. It's 100%. This is because you'll need time to familiarize yourself with Kedro syntaxes and carefully plan out the project architecture beforehand. However, once you do this, especially with similar models, then any development process becomes much faster and more streamlined. And the second problem is compatibility issues with new versions. Well, we realized that, for example, a project written in Kedro version 18.6 may not work in version 19. This can be a setback. However, as previously mentioned, compatibility challenges could be overcome by isolating the model within Docker container. So you keep the version in Docker container constant, and that will be okay. So now my presentation is coming to the end, and I'm ready to answer the questions if you have some. So thanks a lot.
Right, everybody. If anyone has any question, you can go ahead and ask Mr. Alexey. We can take around 3 or 5 more minutes to answer the questions.
Okay. During the presentation, my camera did not work, right?
I'm sorry?
During presentation, my camera did not work, right?
The presentation, it was visible. Yeah, it worked.
Okay, that's great. Because I opened and realized that it turned off.
You just turned it off just a second ago. I believe when you switched to your camera, it just turned off. Right, so I can see no one has just asked any questions so far.
Okay, well, it was a pleasure to share my experience for you.
I see. Well, actually, thank you, Alexey, for sharing all these important information with us. It's much appreciated, and I believe that since nobody asked any questions so far, so yeah, that's pretty much of it. So in that case, I believe that this is going to be all for today. You want to add something at the end?
Yeah, I will send to organizers the whole presentation so they could share you in email, I think.
Perfect. And I can see that Mohammed Sabri is saying that he has a question.
He tries to speak, but
yeah, they will be writing the questions, and you can just answer to the questions in the chat.
Yeah, okay, that's great. Why it's better than cookie cutter? Well,
yeah, I think that I just given that
because of
he will be asking the question right now.
Yeah.
Mohammed Sabri, you can ask us the question. I just give him the permission.
Yes. Hi. Thank you for the amazing presentation. I have limited experience with cookie cutter, and I was wondering why. Do you think if it's structurally better than cookie cutter? I understand the Kedro visualization tool is just, I haven't been exposed to it before, and it's absolutely fascinating. But I see there's just slight differences in the pipeline structure to cookie cutter, and I was wondering if you have some comments about the difference in the directory setups and the structures compared to cookie cutter. Thank you.
Thank you for your question. Well, for me, the difference was really just in visualization. I know that there are a little different structures, but there is no actually difference in running. Well, I don't know, does cookie cutter supports multi-core threading run from the box? I mean, so you won't have to code all these things that to parallelize the calculations. And here it's available from box, so you could run, and that's all. So to my mind, that's the two things that's a better than in cookie cutter. Yeah. Thanks.
Okay, Mohammed, did that answer your question? Is it all good?
Thank you.
Perfect. Okay, so I believe no more questions. So well, actually, thank you so much, Alexey, for such a strong close for today's program. It's highly appreciated. And guys, I believe this is all for today for Stream 3. We'll be waiting for you to join us tomorrow again at 10 a.m. for another round of expert insights. And until then, just have a great evening, and see you soon, guys. Hope you're all going to have a wonderful evening, and for you as well, Alexey. Hope you'll be having a wonderful evening. Thank you, guys. You have a good one.
Bye.